Okay, so this problem involves a ladder. So it says OSHA safety regulations require that the base of a ladder be placed 1 foot from the wall for every 4 feet of ladder length. So you have a ladder, okay, against the wall. So here's the wall. That's the wall. And then here's the ground. And then the ladder is, over here. This is our ladder. Okay. Now, it doesn't tell us how long the ladder is, okay? But it's 4 times some length, okay? So say it's a 20-foot ladder, then it's 4 times 5, right? Okay. So you would take whatever your ladder length is and you would divide it by 4 to find that x, okay? Why am I writing it that way? Well, I want to write it so that I can get this proportion thing going. So it's placed from the ground, away from the ground, 1x for every 4 feet. Okay, so that's the ratio, is 1x on the ground to 4x on the ladder. Okay, so let me give you a real example here. So let's say this is 20 feet, then this is going to be 5 feet, right? Okay, so, and if the ladder was 100 feet, then this would be 25 feet, right? Okay, so you can think about having this value of x, like 25 times 4 is 100, and 5 times 4 is 20. And so 1x, we don't know what the x is. I mean, it's probably not a 4-foot ladder. I mean, I guess it could be, but that's kind of small. Anyway, that's this ratio here. So there's some like value here that we don't really know what it is, but it's consistent, okay? So now we have to figure out, find the angle that a ladder of any length, so we don't know the length of the ladder, but we can find the angle that the ladder forms with the ground. Okay, so that's going to be my theta right there. So I'm going to do that part first, and then we'll talk about the second part of the problem. Okay, so we have an angle, great. So we can talk, it's a right triangle. So we can talk about the ratios here and a trig function. So you have adjacent and you have the hypotenuse. That means cosine. So cosine theta is going to be 1x over 4x. But see, those x's cancel out. Okay, so they're out. And that's why you can do it for any length of ladder. So theta is going to equal the inverse cosine of 1 over 4. Now you can put that in your calculator. And you're going to get, let's see if I did that on my calculator. I did. So it's like, and I did it in degrees again. So 75.5 degrees. Okay, so that's the angle that OSHA says you have to have your ladder at. Okay, so that's that part. Now it says, find the height at which the ladder touches the wall. So now what we want to know is, we want to know this distance right here. Now I already used the x, so I'm going to use a y here. We're not going to be able to figure out an exact value here because, I mean, I shouldn't say it that way. We're not going to be able to figure out the value because we don't know the height or the length of the ladder. But we get it in terms of x. Okay, so that's what we'll do. We can use the Pythagorean theorem. So we have 1x squared plus y squared equals 4x squared. Okay, so we're going to just get this in terms of x is the best we can do. All right, so that's x squared plus y squared equals 16x squared, or y squared equals 15x squared, or y equals the square root of 15x squared, which means y equals x times the square root of 15. So we have, that ratio. If we knew what x was, if we knew how long the ladder was, we could divide it by 4, and then we could figure out, how high up on the wall the ladder is going to touch. Okay? So we have to do that in terms of the variable x that we don't No. Okay. And this is in feet. So I didn't write feet, but should say x square root 15 feet. Okay? Then if you know how long your ladder is, you can figure that out. All right.